So we are in chapter 17 now, and the big concept that we're going to use in chapter 17 is going to be voltage. And now voltage is going to be measured in volts, and that's going to have a symbol of capital V named after Volta. Now it's going to have a lot of names. It's going to be electric potential, So, voltage is going to have a lot of synonyms. Electric potential difference, potential, electromotive force, or just EMF. So there's a lot of things there, and the book is going to use electric potential and electric potential difference a lot. But you're going to see, or they're going to use electric potential, and they're going to use potential difference a lot. But it's got a lot of names, but it's basically just voltage. And so basically what we're going to talk about is you've got some fixed charge. So I take a fixed charge and I nail it to a table. Now I'm going to have a second charge that can be moved. And so I'm going to move it from point A to point B. Now this thing is putting it, now if you just sort of think about it for a second, you know that like charges repel. So if I'm taking this charge and moving it from here to here, I'm going against that repulsion. And so if I'm going against that repulsion, I must be doing work on it. So I am doing work. And so since I'm doing work, this charge is gaining potential energy. Okay, so it's gaining potential energy. And so the equation that we're going to have is the potential energy that it's gaining is going to be K Q1 Q2 over R. So the potential energy gained is going to be K Q1 Q2 over R. Well, let's see, R1 minus K Q1 Q2 over R2. So we're going to say we've got, so this is at R1 and this is at R2. So I have to figure out something that's happened here and something that's I got to figure out some quantity here and some quantity here, and I have to subtract them. And so that's why we get this word difference showing up here. So I have to calculate it twice and then take the difference. Okay, so now let's just forget. Now, like we had in the previous chapter, we had F equals K Q1 Q2 over R squared, and then we had F equals EQ, and we had E is KQ over R squared. So we sort of separated it out. So instead of instead of considering two charges that are interacting with each other, consider the electric field So instead of considering two charges interacting, Q1 and Q2, let's consider the electric field produced by one charge, and then let's consider the effect of that electric field on another charge. So we figure out what the electric field is, and then we figure out what the effect of that electric field is on a second charge. So we're basically breaking this one equation into two concepts. And so we're going to do the exact same idea here. What we're going to do is we're going to say that PE equals, we're going to say that the potential energy equals negative KQ1 Q2 over R squared, over R rather, just R, not squared. And we're going to break that into PE equals Q delta V, and we're going to say that, I'm just going to take out the delta too, I'm simplifying it down, and we're going to say V equals KQ over R. And so we're doing the exact same thing up here. And so this V is the voltage. And so it's sort of like but of course it's not a hill at all. It's not three dimensions. There's no gravity. So it's really, this is just sort of like it's a flawed analogy. But voltage is kind of like how high is the hill that the other charge needs to climb. If I have a very, very high charge here, then that hill is going to get steeper and steeper and steeper as I make that charge more and more and more. Okay. So I'm going to leave that, and we're going to continue talking in the next video.